Hello everyone, my name is Raylan Bovair, and today I'm going to be discussing hydrophilic versus hydrophobic molecules. Hydrophilic is Greek for water-loving, and in biology, it's defined as a molecule being able to have interactions with water. Substances that are hydrophilic tend to dissolve in water. The explanation for why this happens is because hydrophilic molecules are polar compounds. A polar covalent bond occurs when the electrons between two shared molecules are not shared equally. Because of this, the electrons tend to spend more time closer to one of the molecules in the bond. This weak bond makes it much easier for water or other polar solvents to create hydrogen bonds. For example, imagine placing a substance like salt or sugar in a cup of water. The molecules of these substances are polar in nature, with their electrons being dispersed unevenly between the two atoms. The water would then bind one of its hydrogen atoms to the molecule, thereby dissolving it. This ability to form hydrogen bonds so easily is what allows water to be such an amazing solvent. Here we have an example of how water molecules bond, particularly with each other in this example, but it goes to show how it works generally with any molecule. So we see the straight lines here representing a polar covalent bond as described before. And here the dotted lines representing a hydrogen bond, and here exactly is how these water molecules will create bonds in which with other molecules would dissolve them. Oppositely, the term hydrophobic means water-fearing, and they repel water and do not dissolve. What makes them different from hydrophilic compounds is that they contain nonpolar covalent bonds. So what this means is that the electrons are shared equally between the two atoms and spend an equal amount of time dispersed between the two. So because of this, they don't have anything for the water to grab onto and to bond to with its hydrogen atoms. A great example of a hydrophobic reaction would be putting oil in water, and you would see that the oil actually clumps together and does not mix in, and this is because, as I described, these nonpolar covalent bonds, they don't leave any room for the water molecules to create hydrogen bonds that would dissolve them. So instead they kind of clump together, they repel the water, and they do not dissolve. Another great example of this is what is called the lotus effect. So it's when water forms droplets on hydrophobic surfaces instead of spreading out evenly as it would with hydrophilic substances, because on a hydrophilic surface, the molecules are actually attracting the water to spread. Whereas in hydrophobic, they're actually repelling the water, and so they form these little droplets, as you see here in these images, because they lack those polar bonds. Now, in conclusion, a hydrophilic substance is water-loving. It dissolves in water, it attracts water. Hydrophilic molecules contain polar bonds, which means that the electrons are dispersed unevenly between the two, which opens up a chance for water molecules to create hydrogen bonds, which thereby dissolves them. Examples of some hydrophilic substances are sugar, salt, starches, and a hydrophobic substance is water-fearing. It repels water and does not dissolve because it has those nonpolar bonds where there's no room for the water molecule to come in and create that hydrogen bond. And great examples are oils, waxes, and fats. And thank you so much for listening, and I hope you learned something. Bye.